Physics chapter 17, end of chapters, question number 5. A car is traveling around a bend when it hits a patch of oil. The car slides off the road onto the grass verge. Explain using your understanding of circular motion why the car came off the road. So basically what happens is here, now there is a car traveling on a straight line. This car then takes a bend. So then, but because there was a patch of oil here, the car couldn't take that bend. So that means it veered off. So that means it went like this. It took a larger circle. So if you take this blue line, then you can see that it would, assuming that it is the circle like this, then the red one would be a larger circle. It would be a larger circle. The bend is bigger. So that means if you take a if you are to rotate it, you can remember, if the radius increases, the centripetal force is lesser. So that means if there is less centripetal force, the radius is bigger. So that is exactly what happens here. So the road is not able to provide the necessary centripetal force to take this sharp turn, the blue colored line. So because the centripetal force is less, the circle has a higher radius. That means the oil patch reduces the friction between the road and the tire. As a result, it is not able to provide that necessary frictional force. Then we move on to question number 6. Figure 17.20 shows an aeroplane banking to make a horizontal turn. The aeroplane is traveling at a speed of 75 meters per second, and the radius of the turning circle is 80 meters. So now here you have to know about the you have to remind yourself about the vectors, the horizontal and vertical components. I'm not going to teach you that now, but I will. If you have any questions on that, you can raise questions. So here what happens is the force that is making it travel in that travel is the lift. So the lift has two components when it banks, the horizontal and the vertical component. So the lift is L. If you take the lift to be L, then the angle with the horizontal is going to be theta. Angle with the horizontal is going to be theta. So this is theta. So that you must understand. So then vertically, then it would be L sine theta, and vertical component is mg. You know that. Vertical component is L sine theta, and that is mg. Right? If you have any doubts, please use trigonometric ratios and draw the triangles and see how it connects. So that is equal to mg. Then the horizontal component is L cos theta. Horizontally you would have L cos theta. L cos theta is then, that is the L is the lift, L cos theta, that is equal to F. That is what gives the centripetal force. That is mv squared upon r. mv squared upon r. So now the combination between all of these is actually the you can combine them all to get a different value. What is that value? That would be the tan value. If you combine the sine and cos, if you know sine and cos, then you obviously can find the connection between sine and cos. Then tan theta is going to be equal to, you will have to try to figure this out. If you have any difficulties, once again, like I said, please raise questions. So let me clear this. So tan theta is going to be tan theta is going to be when you combine the sine and cos equation, tan theta is going to be m to m would get cancelled out when you combine sine and cos. You will be left with rg upon v square. Rg upon v square. Now they have given the radius of the circle to be 80 meters. So 80 into 9.8 divided by v squared is 75 square. 75 is the rate at which it is traveling. So then tan theta, you would get, if you use the calculator, you will get tan theta to be, you will have to use the calculator there, tan theta to be 0.139, and if you find the inverse of tan, you will get theta to be 7.9 degrees. 7.9 degrees. I hope you understood this. If you have any further questions, please raise them.